Hello viewers, I'm Madhavi and I'm here to discuss about isotonicity. This presentation is intended for the undergraduate students of B.Pharm program and I hope others find it useful too. Let us begin with water. Water, you know, freezes at 0 degrees centigrade. Are you aware that seawater freezes approximately at -2 degrees centigrade? Yes, and you know the reason. It is because of the presence of soluble non-volatile solute, which is sodium chloride, majorly. Now, because of the presence of a dissolved solute, the freezing point has dropped from 0 degrees to -2 degrees. Which means this phenomena is called depression in freezing point, which is a colligative property. Colligative properties are those properties which are dependent on number of entities or species that are present in a system. The same phenomena of colligative properties has another implication, which is osmotic pressure and osmosis. You must have heard of it. Now I'd like to use some props just for the sake of a conceptual clarity. Now here I have two bottles A and B. Imagine they are cells. Now if both A and B had just water and they are separated by a semi-permeable membrane, there would be no net movement of water molecules, because it's just water on either side. Now, this is A and I mentioned marked here as 6. So, I want to put 6 solute particles which are soluble into system A. So, here we go, little noisy there. And then, here I have system B, in which the solute particles are 10, right? So here I go, little noisy. Now, if A and B are separated by a semi-permeable membrane, at constant volume systems, you see that the blue color is the solvent and it is more in A, right? And here it is B, the solvent is very less. In this scenario, when A and B are separated by a semi-permeable membrane, the movement of solvent molecules from a region of their higher concentration to a region of their lower concentration across a semi-permeable membrane. Please assume this as a semi-permeable membrane. This phenomena is called as osmosis. In other words, this is a lower concentrated solution. It has only 6 solute entities. This is a higher concentrated solution. It has 10 solute entities. So the movement of solvent molecules from a lower concentration solution to a higher concentration solution across a semi-permeable membrane is termed as osmosis. I hope you're clear. Osmosis is the movement of solvent molecules from a region of their higher concentration to a region of their lower concentration across a semi-permeable membrane. This phenomena is called as osmosis. Now I have some raisins here. You can see this is the dry original raisin, completely devoid of water. Now observe these packs. This is pack 1. I hope you are able to see it. And this is pack 2, right? Yes, you have observed right. The packs are swollen, the raisins are swollen. And let me tell you why. I put them in water, right? So, water moved from its higher concentration in the bowl across the cell membrane of the resin into the resin, from its region of higher concentration to its region of lower concentration, right? So that phenomena is called osmosis. And if I don't want the solvent molecules to move, let us say solvent is moving from A to B, I want to stop this movement. The pressure that I need to apply on the concentrated solution to prevent the movement of solvent molecules is the osmotic pressure, which is the driving force. You understand? So, the pressure that is required to prevent the movement of the solvent molecules from a lower concentration solution to a high concentration solution, that is called as osmotic pressure. Now, determining osmotic pressure or quantifying it is done based on two parameters, which is called osmolality or osmolarity. What are these? Osmolality is a term which talks about number of osmoles present in 1 kg of the solvent, whereas osmolarity is talking about number of osmoles present in 1 liter of the solution, right? Now, osmolality, what is osmol? It is talking about the number of species which is reflecting the colligative properties. So, 1 osmol is equal to Avogadro number of species, right? N 6.023 into 10 power 23 species in the solvent system. So, an electrolyte like sodium chloride, 1 mole of sodium chloride would give 2 osmoles. 1 osmol is the Na plus ion, the other osmol is the Cl minus or the chloride ion. So, systems which are having the same osmolality or osmolarity are termed isoosmotic. And if a solution is having more osmoles, it is hyperosmotic, and lesser osmoles, it is hypoosmotic, right? So here the serum, a serum has got an osmolality of approximately 275 milliosmoles per kg or approximately 300 milliosmoles per liter, which means if you have an injection which is having lower osmolarity, let us say 200, 150 or so, it is hypoosmotic. Solvent from the injection would get into the cells, right, because of the difference or because of the osmotic pressure. Similarly, if you have an injection which is around 350 or 320 milliosmoles, it is hyperosmotic, right? It would withdraw the fluids from the cell into the formulation. Okay. So now, how do you measure this osmolalities? It is done by an instrument called a cryoscopic osmometer, and it measures the principle based on the depression and freezing point. And I told you depression and freezing point is because of the number of entities that are present. So, plasma or the serum, if it is just water, it would freeze at 0. But plasma has so many entities that they are contributing to a lowering of the freezing point from 0 to minus 0.52 degrees. And here the fluids, 0.9% sodium chloride, 1.9% boric acid. They are isoosmotic with plasma. You get it? 0.9% sodium chloride, 1.9% boric acid are isoosmotic with plasma. So where is the question of isotonicity? Isoosmoticity is a physical phenomena, whereas isotonicity is a physiological phenomena. When you are talking about physiological, you are talking about the relationship with the specific body fluids, right? We are talking with the relation. So now, if you take boric acid solution, 1.9%, it is definitely isoosmotic with plasma. But is it isotonic? No. Boric acid solution is isotonic with lacrimal fluids or the tears, but it is not isotonic with plasma. Why? Because the red cell membrane is freely permeable to boric acid. So the moment you put boric acid in the plasma, it happily enters into the blood circulation and leads to destruction of the cells. I hope you're clear the difference between isoosmotic and isotonic. Isotonic is given with the physiological fluid reference. Osmotic is just with a physical reference. So all these three, your plasma 0.9% boric acid, 1.9 are having the same osmolarities. Okay. Now coming to the last part, again I am using some props to demonstrate the same. So here I want to make a injection. I want to make a formulation. I have selected some props. See, the pharmaceutical systems have a range of additives that are used. You are using the API. Now I have chosen this just to represent the API, and I have the co-solvents, ethanol and glycerin. I have other additives here, sucrose. Then we have preservatives, we have antioxidants, we have buffers. So many entities are present in the system, right? Now this is system C. Okay, I'm making a formulation. Here is my vehicle. I'm adding some amount of water. That's the vehicle. Specified volume. So please understand, this is only a representation for a conceptual understanding. So I am adding my API here. It's going into the formulation or the vehicle system. Now the number of APIs I have chosen, I assumed that each API is contributing to only one molecular species, right? So I have taken the API as 20. Then I have taken here ethanol, that is here 5. Each one is contributing to only one. Then I have glycerin. So again here I have got around 6. Then next one I am putting in some amount of dextrose, right? So that is coming to 7. See, this is my formulation. I am making the molecules visible to you, right? Yeah, they are not molecules, they are just models for understanding. Then we have some amount of sucrose here. So this is sucrose I have taken. Next, coming to the interesting part, I put 1 sodium chloride. So 1 sodium chloride is giving how many osmoles? You have 1 sodium and 1 chlorine. You are having 2 species in solution. Similarly, I am putting the preservative sodium benzoate. You have 1 sodium and 1 benzoate. Next, antioxidant sodium ascorbate, 1 sodium, 1 ascorbate, right? So I am putting 2 molecules. So now this is my system C, which is having a total number of entities as 49. I have calculated it, right? Now this is system D. Both C and D are very close to each other. The only difference I have done or I have used is in C, I took the antioxidant as sodium ascorbate, whereas in D, I have taken the antioxidant as sodium thiosulfate. So what is the difference? Just let me add it. Each sodium thiosulfate is contributing 3 entities, 2 sodium ions and 1 thiosulfate ion. So total they are giving to 3. Rest of the additives are same. See here, sodium chloride, sodium benzoate, right? Now this is my sodium thiosulfate. I have 1 sodium, 2 sodium, thiosulfate, and I have used 2 molecules of the antioxidant in both the cases. So I have 2 more here, right? Total. Now system D is coming to 51 entities. System D is coming to 51. I am not sure if you are able to see. Is coming to 51. Right. So if I have to make C and D isoosmotic, I need 2 more species to be added to C, because C is 49, D is 51. I choose, this is my boric acid. one boric acid is giving only one entity, right? So this is C with boric acid, this is D without boric acid. Both are isoosmotic because they have same number of species in the solution. Now this is my red cell membrane. If I give this solution, what will happen? Yes, you are right. This boric acid will happily go across and destroy the cell. So this is isoosmotic, but it is not isotonic. Now on the other hand, if I am using a simple I for an ophthalmic delivery, the same formulation, both of them are suitable because boric acid is tolerant to the lacrimal fluids, right? Both system C and system D are suitable for ophthalmic administration, but system C is not suitable for parenteral administration. I hope now we are clear. We have discussed what are colligative properties, what is osmosis, what is osmotic pressure, how we are measuring osmolality, and isotonicity, isoosmoticity, hypotonic and hypotonic. This is a small attempt to convey to you the difference between isotonicity and isoosmoticity. Now the books, the best reference I have taken is Remington's Pharmaceutical Sciences, and so many other standard books are there. Just a little point to add. System C, which had only 49 species, was hypoosmotic compared to system D. So I had to adjust the osmoticity, or let me put it as tonicity, using tonicity adjusting agents. That agent is boric acid that I have used. Now please understand, the numbers are only assumptive. They don't mean anything realistic to the body fluids, right? So for a hypotonic solution, tonicity can be adjusted by addition of tonicity adjusting agents, whereas for a hypertonic solution, it is not possible to lower the tonicity. Thank you. Have a good day.